Hi everybody and welcome to the Arduino Craft Corner. In today's episode I will tell you how to debug an Arduino sketch that runs on an Arduino Uno or on an ATtiny using only open source hard and software and spending not more than 10 euros. So how are we going to accomplish that? So this is probably something that happened to you before as well. You had this brilliant idea for this project and then you came up with an Arduino sketch like this one here. And when you are done with coding, you press upload. Now the thing is uploaded to the Arduino board and now you are going to test it. So it is supposed to cycle through different stages with different blinking patterns when you press a button. Let's see whether this works. Well, you press, nothing happens. Again, you press, nothing happens. Well, we have to find the bugs in this program. And how do we do that? Often you just insert print statements and then you see how the program proceeds. But there's a much more convenient way to do that. And that is using a debugger. The Arduino IDE does not offer such a thing, but there exists this popular open source debugger GDB, the GNU Project Debugger. Okay, usually what you do when you debug a program is that you have a debugger, GDB for example, and then this is used in order to debug the program that runs on the same machine as the debugger. So you start the debugger and then you control the program and do things. If we are talking about embedded systems, then things are a bit more complicated. So there you have a target system that is different from the host where the debugger runs. So now, first of all, the debugger has to know the architecture of the target system. And then, well, it has to control the sketch that runs on the target system. It's not on the host anymore. So how is that accomplished? Well, GDB has means to do remote debugging, that is debugging on a remote computer. And it uses the remote serial protocol for that purpose. So what about the target system? How does that support remote debugging? Well, first of all, almost all microcontrollers these days have something which is called OCD. It's an on-chip debugging hardware. And that allows external components to examine the internal state of the MCU and control the execution. In case of the Arduino Uno and the ATtinys, there a debug wire protocol can be used to control the OCD. Now the debug wire protocol is something completely different from the remote serial protocol. And here we have a missing link. And that is filled by the hardware debugger, which is just an Arduino Uno. And well, we have the firmware DW link running on it. So how do we get there? Well, first of all, we have to install a debugging environment. And that could mean that we download and install PlatformIO. Or alternatively, we just could install AVR GDB. And then we have to do some mods on the configuration files of the Arduino IDE. Okay, that's the first step. Second step is, well, we have to get hold of the firmware and download it and then install it on our hardware debugger. Third, we then have to set up the hardware, which means that, well, we have to connect the hardware debugger to the target, and we also have to do some modifications on the target, perhaps. Well, and fourth, then we can start to debug. And that's all. So 4 easy steps. Okay, let's start with the first step, and we will download PlatformIO. I will show you how to install PlatformIO under Windows, but under macOS and Linux it's basically the same. Okay. So first of all, we have to look for PlatformIO. There it is. And what we want is we want to download it. And first of all, we have to download VS Code, Visual Studio Code. So now VS Code is installed. And what we want to do now is we want to install an extension named PlatformIO. Here it is, and we want to install it. And now PlatformIO is installed. As you can see here, this ant icon, that's the one where you get access to all the different functions in PlatformIO. So in particular, you can open the home window. And what we will do is we will install the PlatformAtmel VR. That's the one we want to install. Okay. So now we can look at projects examples. And what we want is we want this Arduino Blink example. And here we are. So now we have our first project imported. And that's the Arduino Blink project. The source code can be found under the source folder. And this is just the same as we know from the Arduino. Well, there is a slight difference. We have this statement include arduino.h in here because, well, we want to explicitly add all the Arduino stuff. Okay, and then there is PlatformIO ini. This is a file where all the different parameters are set, and I don't want to get into it. Now, when we again select now the end symbol here, and well, let's look at the Uno board. Here we have now different options like building the binary code. So now let's upload the code. And again, we are successful. Okay, and with that, we will stop here. I believe when you work first with this kind of IDE, then you are probably in trouble, but there are very nice tutorials on the web where you can learn about the basic things you have to know. So now the second step, downloading the firmware. So I show you how to do that under Linux, but it is the same under macOS or Windows. Again, we have to start a browser, and now we look for GitHub. That is the platform where you find the firmware. So GitHub, and now on GitHub we search for dwlink, and there it is already. And we download the latest release as source code. It's the zip file. We save it, and that's basically it. Now we only have to move it somewhere where the Arduino IDE can find it. And so let's look into our downloads or folder. There it is. And we need another window. The folder for the sketches, which we find here. Okay, that's where we want to move it. And now we have to extract it. Good. So we don't need this zip file anymore. And what is now the only thing to do is now uploading it to our Arduino board. Okay, so we start the IDE. Okay, now let's load the firmware. We have it here. And we can upload it now to the board, and now we are done and can go to the third step. Okay, the third step, setting up the hardware, and before we do that I have to make a warning. So the warning has something to do with the reset line of your target. This line is used as the communication line with the hardware debugger, and it is a bidirectional open drain line, so it needs a pull-up resistor, and that should have around 10K. Now if it doesn't have such a resistor, the communication doesn't work. If it does have a too high resistance, then it doesn't work, and so on. And well, it also doesn't work if you have a capacitor that is either well connected to ground or to VCC or to some other external device, because then well we don't get any signals across this line. And if we don't get the signals across the line, then it can happen that you can move your target into debug wire mode, but you don't get it back to normal mode. Okay, so the Arduino Uno, for example, they have such a capacitive load on the reset line in order to implement the auto reset feature. And that is something you have to remove before you start to debug the Arduino Uno. And I will show you how to do that. Yeah, you all know the Arduino auto reset feature, which is responsible for resetting the Atmega when we want to upload a new sketch. And that is something we cannot have when we want to debug the chip using debug wire. So what we have to do is we have to disable this feature, and that can be accomplished by opening this solder bridge here. So you take a sharp knife, and then what you do is you go here and then you cut the existing bridge with your knife. And after you have done it, you can try that out by trying to upload a sketch again. And if you get an error message, then you were successful. Now you may ask, can I revert to the earlier stage? Yes, you can, by putting some solder on here. But I keep one of the Uno boards disconnected at that point here so that I can use it for debugging. So we are now ready to connect the debugger with the target. And remember, the target, that's the board where you have cut the solder bridge. So how do you connect these two? Well, before we start connecting, I show you two optional components, but they are very helpful. So one is an LED with the plus lead going into 7 and the minus lead going into 6. Whereby you should put a series resistor in there. And this is then the system LED that tells you about the internal state of the debugger. It's optional, but it's very helpful. Another very helpful thing is a capacitor, which goes between reset and GND. And well, GND is then, of course, the minus lead, and reset is the plus lead. If you have put such a capacitor here, then you don't get the auto reset, and well, that means that the debugger starts a bit faster. It's also an optional thing, but it's helpful. So now let's connect the debugger to the target. And well, we start with connecting GND. And the next thing then we will do is we will connect the SPI lines. And that is SCK, MOSI and MISO, and these are the pins 13, 12 and 11, and well, you connect them one to one from the debugger to the target board. So as a next thing, we connect the supply of the target board. That is the 5-volt pin here, and we connect that to the pin 9 of the debugger. And well, that means that we source the entire target through this pin. Well, that is sort of at the limit because, well, you get maximum 40 milliampere out of here. But it's okay, and it helps you in order to start up the debugging session, because now you can power cycle the board here, and that is essential when you start the debug session. So, and finally, we connect the reset line of the target to pin 8, which is, well, the debug wire control line. And that's basically it, and I'll show you how that looks in reality. So that is how it looks in reality, and that means now we are ready to start debugging. You remember that we had imported the example sketch Arduino Blink to PlatformIO, and that's what we want to use as our first program that we are going to debug. We have to do some small modifications before that though, and that is we have to add one extra file called extrascript.py, and we have to include a modified PlatformIO ini file, and both of these files you can find in the directory where the DW link files are. So it's under examples, and then it's in PIO files, and there you find the two things. Okay, in PlatformIO ini we have to specify some additional things, and that is here for the debugging. We have to say Uno because we are debugging a Uno board, and here we have to place the serial port. That's easy to find out which one it is. So we go to PlatformIO again, then devices, and then devices, and here we see all the connected devices. That's the right one here. Has been copied now, and we can go back to the file PlatformIO ini, and now we replace this. Both of them. And now we are almost ready. The only thing we have to do now is we have to save this file. Depending on the operating system, that may take different characters. Now it is saved. We don't have any dot here anymore, and so we can start debugging. So we click on Run and Debug here in the navigator in the left, and then it comes up PIO Debug, and that's where we click on. And now it is compiled, and wow, here we are. Now we have stopped at the init function, which is an internal Arduino function. And now we can go through the program. So we can look at this kind of icons. Here we can control execution. First thing means we start and run, and that means we make a step over a function. That means we step into a function, out of a function, and that means we restart. So let's step over init variant, and over setup, and now we are entering loop. So let's make a step in, and now we are here at digital write. If we make another step, then the LED will go on, and indeed it does. So we can make another step. Then we wait a second. Now it goes off again. Now we wait a second again, and so on. And we can also set breakpoints, for example, here. So if we now run, we will stop here again. Now we can say again, run, and we stop again at that point here. Okay, that should be enough for now. What we now want to do is we want to close the session. But now remember, our target is still in debug wire mode. We haven't changed that back. We have to do that if we want to use it again as a normal MCU. And the way to do that is we go here back, then to the project task debug, and there we find the custom things, and under custom we find debug wire disable, and that's what we click on, and now it says connected to Atmega, debug wire is disabled. So now the MCU on the Uno board is back to normal and can be programmed as usual. And I guess there are a lot of other things to explore, but that will be done in another episode from the Arduino Craft Corner. Bye bye.